is Ania, and this is my lab partner, Nisha, who's the cameraman. Okay, and this is our lab report for our wind turbine experiment. During this unit, we have been researching alternative energy sources, and so energy sources that are more efficient and are renewable. And the one we chose to experiment with is the wind turbine. And we made a small-scale model to represent a full-size one, and it's just a fan. And we made a simple windmill by using just paper blades, which we attached to a cork using blue tack and paper clips, which is then hooked up to a generator, which through these wires sends the potential V into my computer, and then we can check how efficient it would be in like real life. So, sorry. Yeah. So to get that program up, the program is called. Wait for it. Logger Light 123. And in a second, you will see what it looks like. Any minute now? Yeah. So what we're going to do is we're going to start our experiment. Nisha, can you come over here so you can set the fan for me? Okay, so what we're experimenting with is the different angle at which the blades are set. So for our first test, they are set at a 0-degree angle. So they're facing the wind. So if you could start the wind, please. And, okay, collecting data in now. We're going to run this for 10 seconds. And stop. Okay. So, as this slows down, we have discovered that on average, it's the potential power could create is about 0.135 potential Vs on average. So that's our first test. Okay, so now what we're going to do is we're going to change the angle at which the blades are set. So now we're going to have them. Now we're going to have them at a 45-degree angle. So turn them slightly. Sorry, still turning. Okay, almost there. Okay, good. So now they're at a 45-degree angle. Okay, so are you ready to start the fan again?
Yes.
Okay, and I'm gonna start collecting now. Wow. Okay. The whole thing is moving, which shows us that this is a very good option for for energy. Okay, one of the blades fall off. So, okay, and then now looking at our information, can see that the average amount of energy produced would be point 140 potential Vs. Okay, so our last experiment will be at a 90-degree angle, which is having the blades totally sideways. And just bear with me. Okay, almost there. slight difficulties. Chill. Okay. Okay, almost there. Be mean to me. Shoot. Okay. So, are you ready to run the experiment one more time, one last time? And go. We will start collecting now. Okay, and as you can tell, it really didn't move at all because this is not a very efficient angle for the blades to be put at. Okay, so, yeah, so on average it was just pretty much zero energy.
Oh my.
Yes, correct. Okay, and Nisha, can you tell us what some of the dependent variables were in our experiment? Please?
Well, there was only one dependent variable, and the dependent variable is, of course, what? Oh yeah, it's what you, oh yeah, what you change.
Okay.
The dependent variable is, what you measure.
Okay, so, Nisha is just joking with you guys. Okay, so...
I'm a funny person.
But what we did to make sure that this experiment was as accurate as it could be, we made sure that each of the blades were spaced exactly the same in between each one. There was the same amount of space, and that each time, see, there's the same amount of space between each of them, and that the windmill was placed at the same distance from the fan every single time.
Muy bien.
And before we started collecting data, we waited 3 seconds with each thing, and we kept it on the same amount of power with the exact same fan. And that made sure that, you know, that only one thing would change during each one, so that our results would be accurate. But one thing we could do better for next time is one of the things fell off, one of the blades fell off because it wasn't properly placed, and also cork is not a very, stable, fast substance, so it kind of fell apart a little bit. So that's how we could have improved the experiment, by choosing better materials and fastening it better and just making sure everything was
Thank you.
ready to go. Thank you. That is our experiment. So.